A kinetic bombardment is the hypothetical act of attacking a planetary surface with an inert projectile, where the destructive force comes from the kinetic energy of the projectile impacting at very high velocities. The concept is often encountered in science fiction and originated during the Cold War. The typical depiction of the tactic is of a satellite containing a magazine of tungsten rods and a directional thrust system. When a strike is ordered, the satellite would break one of the rods out of its orbit and into a geostationary position while directly over the target. The rod would then begin to fall towards the Earth, picking up immense speed until it reached terminal velocity shortly before impact. The rods would often be shaped so as to increase the terminal velocity. In science fiction, the tactic is often depicted as being launched from a spaceship, instead of a satellite. Kinetic bombardment has the advantage of being able to deliver the projectiles from a very high angle at a very high speed, making them extremely difficult to defend against. In addition, projectiles would not require explosive warheads, and in the simplest designs would consist entirely of solid metal rods, giving rise to the common nickname rods from God. Disadvantages include the technical difficulties of ensuring accuracy and the prohibitively high cost of positioning ammunition in orbit. Real-life concepts and theories. Project Thor is an idea for a weapons system that launches kinetic projectiles from Earth's orbit to damage targets on the ground. Jerry Pournelle originated the concept while working in operations research at Boeing in the 1950s before becoming a science fiction writer. The system most often described is an orbiting tungsten telephone pole with small fins and a computer in the back for guidance. The system described in the 2003 United States Air Force report was that of 20-foot-long, 1-foot diameter tungsten rods, that are satellite-controlled, and of global strike capability, with impact speeds of Mach 10. The time between deorbiting and impact would only be a few minutes, and depending on the orbits and positions in the orbits, the system would have a worldwide range. There is no requirement to deploy missiles, aircraft or other vehicles. Although the SALT II prohibited the deployment of orbital weapons of mass destruction, it did not prohibit the deployment of conventional weapons. The system is not prohibited by either the Outer Space Treaty or the Anti-Ballistic Missile Treaty. The idea is that the weapon would inflict damage because it moves at orbital velocities, at least 9 km per second. Smaller weapons can deliver measured amounts of energy as small as a 225 kg conventional bomb. Some systems are quoted as having the yield of a small tactical nuclear bomb. These designs are envisioned as a bunker buster. In the case of the system mentioned in the 2003 Air Force report above, a 6.1 ma, 0.3 m tungsten cylinder impacting at Mach 10 has a kinetic energy equivalent to approximately 11.5 tons of TNT. The mass of such a cylinder is itself greater than 9 tons, so it is clear that the practical applications of such a system are limited to those situations where its other characteristics provide a decisive advantage. A conventional bomb warhead of similar weight to the tungsten rod, delivered by conventional means, provides similar destructive capability and is a far more practical method. Some other sources suggest a speed of 36,000 foot per second, which for the aforementioned rod would amount to a kinetic energy equivalent to 120 tons of TNT or 0.12 kT. With 6 to 8 satellites on a given orbit, a target could be hit within 12–15 minutes from any given time, less than half the time taken by an ICBM and without the warning. Such a system could also be equipped with sensors to detect incoming anti-ballistic missile-type threats and relatively light protective measures to use against them. The highly elongated shape and high density are to enhance sectional density and therefore minimize kinetic energy loss due to air friction and maximize penetration of hard or buried targets. The larger device is expected to be quite good at penetrating deeply buried bunkers and other command and control targets. The weapon would be very hard to defend against. It has a very high closing velocity and a small radar cross-section. Launch is difficult to detect. Any infrared launch signature occurs in orbit, at no fixed position. The infrared launch signature also has a small magnitude compared to a ballistic missile launch. One drawback of the system is that the weapon's sensors would almost certainly be blind during atmospheric re-entry due to the plasma sheath that would develop ahead of it, so a mobile target could be difficult to hit if it performed any unexpected maneuvering. The system would also have to cope with atmospheric heating from re-entry, which could melt non-tungsten components of the weapon. The phrase "rods from God" is also used to describe the same concept. An Air Force report called them hypervelocity rod bundles. In science fiction, perhaps the earliest examples of kinetic bombardment come from E. Doc Smith's 1930s and 1940s Lensman series. In these books, however, planetary masses were used rather than smaller projectiles. It was in the mid-1960s that popular science interest in orbital mechanics led to a number of science fiction stories which explored their implications. Among these was The Moon is a Harsh Mistress by Robert A. Heinlein, in which the citizens of the Moon bombard the Earth with rocks wrapped in iron containers which are in turn fired from an electromagnetic launch system at Earth-based targets. In the 1970s and 1980s this idea was refined in science fiction novels such as Footfall by Larry Niven and Jerry Pournelle, in which aliens use a Thor-type system. During the 1980s and 1990s references to such weapons became a staple of science fiction role-playing games such as Traveller, Shadowrun and Heavy Gear, as well as visual media including Babylon 5's Mass Drivers, and the film Starship Troopers, itself an adaptation of a Heinlein novel of the same name. A smaller crowbar variant is mentioned in David Sling by Mark Stigler. Set in the Cold War, the story is based on the use of information-based intelligence systems to overcome an enemy's numerical advantage. The orbital kinetic bombardment system is used first to destroy the Soviet tank armies that have invaded Europe and then to take out Soviet ICBM silos prior to a nuclear strike. This becomes relevant in Neal Stephenson's Anathema when a kinetic bombardment weapon is deployed from orbit to trigger the eruption of a dormant volcano. From the mid-1990s, kinetic weapons as science fiction plot devices appeared in video games. Appearing in Bullfrog Productions' 1996 Syndicate Wars as a player-usable weapon, it also featured prominently in the plot of Tom Clancy's End War, Mass Effect 2, Call of Duty, Black Ops 2 Unnamed Kinetic Strike Weapon, Call of Duty, Ghosts Odin and Lockheed Strikes, as well as Mac from the Halo franchise, to name some. In 2013 a kinetic weapon bombardment system consisting of tungsten rods in an orbiting platform, codenamed Project Zeus, was featured in the movie G.I. Joe, Retaliation. See also, Kinetic Energy Penetrator, Relativistic Kill Vehicle, Prompt Global Strike, Brilliant Pebbles, Railgun. References. Further reading, U.S. Air Force Transformation Flight Plan, United States Air Force, November 2003. Space Weapons, Earth Wars, RAND Corporation, 2002, ISBN A0-8330-2937-1. External links, Rods from God weeklystandard.com. Rods from God. Popular Science. June 2004. Rishad L. Garwin. Space Weapons, Not Yet A.